Alrighty. Today's video we're going to be doing 28 complex numbers. Big things about it is what makes a complex number. It has a real part and a imaginary part. All right, so typically you see it in the form of a plus bi. We classify things that are complex with the bolded C. So you might see something like that. So it tells you that element is a complex number. The A part is the real part, meaning it's a real number. And the BI part is the imaginary part, which basically has an imaginary number. Now the I is equal to the square root of -1. And the reason we have this because we cannot take the square root of a negative number. Biggest question I always get, well, if there's not a square root of a negative number and it doesn't exist, then why do we deal with it at all? Well, we found out that if you take I times I, you get I squared, which is then the square root of -1 squared, which ends up being -1. So even though I is not real, I times I does give you a real number. So therefore we keep playing with it. So we then learned, all right, well, I times I would be I cubed. That actually just gave us -1 times square root of -1, which gave us negative square root of -1, which we just called negative I. And then we learned if we do I times I times I times I, we would get I to the fourth, which is pretty much I cubed, which is negative square root of -1. We get negative square root of -1 squared. Oh, I've had the square root of that because that would be that times that. That cancel, then you'd be left with -1, which gave us a positive one. So we saw four imaginary numbers does give us a real number. And then we saw that I times I times I times I times I, which is I to the fifth, would just be 1 times square root of -1, which would just give you square root of -1, which takes us back to I. So we saw that it just repeats itself every 4 times. So the pattern goes hold on. I squared would be -1. I cubed would be I to the fourth would be 1. And then it repeats. So then I to the fifth is just equal to I second, or I to the sixth would be -1, and so on, and so on, and so on. So this is a very important pattern that you need to know. And this is basically what makes up a complex number. It's pretty much. Oh, we talked about with radicals, but we'll talk about them here as well. There is a complex conjugate, which just basically means if I have A plus BI, its conjugate would then be A minus BI. So we do the same thing we did when we had radicals as well. And that was back in section 1.4. But that's pretty much everything that you really need to know out of the section. So let's get some practice problems. So we're going to look at number 1 on page 81. It is the square root of -25. And you're just asked to evaluate the square in I. So even though you type this into the calculator, it gives you a non-real answer, and that'd be true. It's a non-real answer. However, this does give us a imaginary answer. So what we do is anytime you have a negative inside of an even index, so in this case a square root, we're going to automatically pull out the I and then just evaluate what the positive square root of 25 is, which in this case is 5. Now, I wrote it like this. However, it is proper to write the number and the I last. All right. So practice, a lot mathematicians will put the I over here. But what I've noticed with students is they think the I is still inside the radical. I want you to clearly see that the negative came out as an I. Then I evaluated the positive 25 to get the 5, and this is kind of how it looks, but this is the proper way to write it. All right. So let's look at number 2. This is the square root of negative 12. So again, I'm going to pull that I out, and then I'm going to evaluate 12. Two things that multiply to 12 is 3 and 4. 4 breaks down into 2 and 2. It takes 2 of the same numbers to come out. So this will become 2i, square root of my leftover, which is 3. I think this is proper. A lot of mathematicians argue that this is proper, and this is probably more proper than this one. Just be cautious that that I is not in the radical. So this is actually a better answer. I don't mind this one, but if it tells you you're wrong, just make sure that I in the end here. Let's look at number 4. This one is negative square root of negative 100. So again, I'm going to keep that negative, evaluate this negative as an I. So this negative stayed here, this negative became an I, and I'll reevaluate with the square root of 100, which is 10. That makes this negative 10I. All right, so that's the easy ones. Let's jump into number 9. Number 9 says to simplify the complex expressions. So we have 4 minus 2i minus 3 plus I. This is just like in the earlier sections. The best route in the middle. And then from here, you just kind of work out. So this would be 4 plus negative 3, which is 1, and then negative 2i plus negative I, which gives you negative 3i. Always write the answer in A plus BI form. So the real part first, imaginary part second. All right, let's look at number 15. When you see something in the form of 5 minus 3i squared, this means you have 2 of them. So this would be 5 minus 3i times 5 minus 3i. And so then we can just work this out. So 5 times 5 is 25. 5 times negative 3i is negative 15i. Negative 3i times 5 is negative 15i. Negative 3 times negative 3 is positive 9i squared. So this is where this part comes into play. I squared is equal to negative 1. I cubed is equal to negative I. And I fourth is equal to 1. And then it repeats. So this I squared here, we really want to replace it with a negative 1. So that 9 times negative 1 actually gives us negative 9. So then when we combine like terms, we go 25 minus 9 gives us 16. And then negative 15i minus 15i is negative 30i, not I squared. I'm just combining like terms. All right, so basically 9i squared is the same thing as just negative 9, or any number I squared is basically the opposite sign of that original number. And there you go. All right, let's look at another one. Let's look at 16. 16 is 5 plus I times 2 minus 9i. So again, we'll go through the same process. 5 times 2 is 10. 5 times negative 9i is negative 45i. I times 2 is positive 2i. I times negative 9 is negative 9i squared. Once again, this I squared is a negative 1, which will make this negative 9i squared become a plus 9. So 10 plus 9 is 19, and then negative 45i plus 2i would be negative 43i. All right, I'll probably do another one. So let's do 18. That'd be 9 minus 4i times 9 plus 9 times 9, which in this case is 81. 9 times 4i, which would be plus 36i. Oh, this is a 3. 36i. Negative 4i plus 9i would be negative 36i. And then negative 4i times positive 4i would be negative 16i squared. I squared turns into a negative 1. This negative 16i squared then is a positive 16. So 81 plus 16 is 97. And 36 plus negative 36 is nothing. So 97 is your answer. Notice as well, this 9 plus 4i is the conjugate. And if you remember with the radicals, when I multiplied a radical binomial with its conjugate, I also ended up with a real number. So this is the same process in the same sense that I is equal to the square root of negative 1. So technically, this is still one of those binomial radicals in which why this stuff works. So therefore, that's kind of what you're left with. Right. So if you notice, it is just going to be the conjugate. And you can simply just say 9 times 9 is 81. And then negative 4i times 4i gives you negative 4i squared and skip the middle part if you notice. Right. But you can see that you get the same concept no matter what. All right. Let's look at number 20. I to the 132nd. So you could do I, I, right? And I squared equals negative 1, then I cubed is negative I, then I to the fourth is equal to 1, I to the fifth is I, and so on and so on. Or you can notice that if you divide by 4, right? If I divide that by 4, whatever this answer is, if it goes into it with a remainder of 1, then it's equal to I. If it had a remainder of 2, because if you think about it, and the answer would have been I. If it has a remainder of 2, the answer is negative 1. If it has a remainder of 3, the answer is negative I. And then if it has 0 remainder, meaning it went into it evenly, so it's a 4, the answer is 1. All right. So in this case, 4 goes into 132 times. Let's see, 4 goes into 13 4 times. Nope. 3 times. Just 3 times 4 is 12. And then 4 goes into 12 3 times as well. So that was even. I don't care what this result is. I'm just seeing, does it go into it evenly? Basically, what's the remainder? In this case, the remainder is 0. So that means the answer here is 1. All right. And that's it. So you got to be able to do that quickly. So you don't want to be there all day on 132i just get to the answer. So remainder of 1, I. Remainder of 2, I squared. Remainder of 3, I cubed. No remainder, I fourth. And remember, it goes I, negative 1, negative I, 1. So these are the official answers that they're looking for. All right. Let's look at number 35 then. 35 is I to the negative 25th. So what you do here is you got to get rid of this negative exponent. So you're going to bring it to the other side of the fraction. Since there's nothing left up here, we have a 1 as a placeholder. So this is 1 over I to the 25th. And then now I can do the same thing I just did. 4 goes to 25. 6 with 1. Is that remainder of 1? The answer is 1 over I, which is more acceptable in my opinion. But you might also see it as I to the negative 1. I lied. Hold on. Technically, that would be the same answer. But that's not what they're looking for. I forgot this part. All right. So Yes, this does equal I to the negative one, but they don't want negative exponents and they don't want radicals on the denominator. And since I technically equals the square root of negative one, this is a radical. So to rationalize this, we're going to multiply by I. And if we do that to the denominator, I must also do it to the numerator. So this becomes I over I squared, which we know is just negative 1. And to clean this up, I don't necessarily need that 1 there. This is just negative I. So this would be the actual answer here. All right. So a little bit more work to do, but once you get I to the 25th to I, then you're just rationalizing at that point. All right. Let's look at number 37. We have 52 over 5 plus I. So what we're going to do here is we're going to rationalize this by multiplying by its conjugate, just like we did with the radicals. So this would be now 5 minus I. And of course, what I do on the denominator, I must also do on the numerator. So because I'm multiplying by the conjugate, I know it's just going to be 5 times 5, which is 25. And then I times negative I, which I know is negative I squared. So I can just go straight to that point. Here, I'm going to have to take the 52 and distribute. I honestly do not know what 52 times 5 is. Let's see, that would be 250, 260. So 5 goes into 2 10 times. 25, 26, 260. All right, so 260 minus 52i. We're going to clean this up a little bit more. This is 260 minus 52i over, oh, not I, squared, just I, over 25. Well, let's just simplify here. We can do a little bit extra here. I squared we know is negative 1. And then so negative 1 makes a plus 1. So 25 plus 20, 25 plus 1 is 26. I forgot the 52 here, so that's 52i. They do want you to write this again in a plus bi format, so this would be 260 over 26 minus 52 over 20i. If the fractions can simplify, you must simplify those. So 26 does go into 260 10 times, then 26 goes into 52 2 times, and just like that. But don't forget that. There you go. So again, even though at this point you technically could be right, it wants it in this form of a plus bi. So therefore, there you go. All righty. Let's look at another one like this. Let's look at 41. 41 is 5 plus I over 4 plus I. So once again, I'm going to multiply by the conjugate of 4 plus I. So that's going to be 4 minus I. Biggest mistake students make is they usually want to do the conjugate of the numerator as well. We do not care if the numerator has an I. The denominator cannot. So I would multiply again by 4 minus I. Never the conjugate of the numerator. Again, on the top, I know it's going to be 4 times 4, 16. I times negative I, which I know is negative I squared. Here, I'm going to have to fold this out. So 5 times 4 is 20. 5 times negative I is 5i. I times 4 is, oh, no, oh, oh. 5 times negative I is actually negative 5i plus 4i. And then I times negative I would be negative I squared. All right, we'll clean some stuff up real quick. I know that I squared is a negative 1. I know a negative and negative 1 just makes a plus 1. Same concept here. So I got 20 plus 1, which would be 21. Negative 5i plus 4i would give me just negative I. And then 16 plus 1 is 17. And again, I want you to rewrite this in a plus bi format. So this is 21 over 17 minus 1 over 17i. There's always an imaginary 1 right there. So I can make it 1 over 17. All right, let's do one more, and that should be everything that you need for your Let's look at number 46. Again, we just want to simplify this. So we're given the square root of negative 9 times the square root of negative 2. So I have to clean up the inside before I can actually multiply. So what I did right here, I'll be Alright, so this right here, the other 9 is 3, so this is really 3i times I square root of 2. So when I do this, I get now 3i squared times the square root of 2, which I now know the square root of 2 is just negative 1. So this gives me negative 3 square roots of 2. So this will be its final answer. Biggest mistake students make is let's say, oh, it's just positive 18, and they'll go 3, 6, 3, 2, and they'll say the answer is 3 square roots of 2, but that would be wrong. The answer is negative 3. You have to pull out the i's first, simplify if you can, and then you can go through and multiply. So at this point, I could do 9 times 2, which is 18, and then get the 3 square roots of I, or 3 square roots of 2, but the I times I becomes I squared. So watch out for stuff like this. You got to take that I out before you can just do the radical stuff. All right, so that's pretty much everything in 1.8. As always, if you ever need more help, please reach out by email. Other than that, I will see you in the next video. Bye for now.